Hi, welcome to the Center of Math's problem of the week. This week our problem is find the basis of the null space of matrix A, and A is this 3x4 matrix. The null space is all the vectors in R4 that satisfy this equation. So when they're multiplied by A, we get the 0 vector. And the first step is to transform matrix A into reduced row echelon form. We used row elementary operations. We took the second row and subtracted off 2 times the first row. Then we took the third row and added the first row to it, which gave us this matrix. And then we multiplied the second row by -1, and we took the third row and subtracted off the second row, which gave us this matrix. And then our last step was to take the first row and add the second row to it. And this is our reduced row echelon form of the matrix. And each column corresponds to a variable x1, x2, x3, x4. We can write this matrix as a system of equations. So the first row, we get this equation, x1 plus x2 plus 5x4, and our second row gives us x3 plus 3x4 is equal to 0. From our matrix, we can clearly see that the leading ones are in column 1 and column 3, which means that our free variables are x2 and x4, and we can assign any value to them. We're going to let x2 equal s and x4 equal t, where s and t are just any real numbers. So we have x2 is equal to x, and we have x4 is equal to t. And from our system of equations, we can solve for x1 and x3. Just subtract x2 and 5x4 from both sides, and subtract 3x4 from this side. And now we can just plug in s and t for x2 and x4. So then we get our column vector is -s minus 5t, s, -3t, and t, and we can split up this vector into 2 separate vectors. And once we split it up, we see that our bases in the null space are just these 2 vectors. Thank you for watching. I hope you enjoyed this video. Be sure to check out our blog, check out centerofmath.org, and follow us on Twitter and Facebook. Thank you.